Computer. Okay. All right. Well, welcome everyone. I gave a brief introduction there that wasn't recorded, but let me start the official presentation with a screen share. And I want my entire desktop, and here we go. Okay. And I just want to verify that everybody can see this. Let me start. Okay. Is everyone able to see this? Okay.
Yep, looks good.
All right. Okay, this is entitled Patterns for Jupyter Notebooks in Machine Learning. And I'm not really sure what the right title is, but this is an attempt. And we'll see what I mean here in a moment. So I'm Garrett Smith. My background is in engineering. I'm a programmer. Lately, I've been working in Python as is sort of the primary language in machine learning, and to some extent data science. Prior to that, I did a lot of work in distributed systems. So Erlang was my primary language, but I have a background experience in C, C++, Java, but back even before that, Visual Basic and Pascal. So I've seen a number of languages and approaches to languages. That's my background. I'm not a data scientist. I'm not trained in the mathematics or the academic side of machine learning. My intent is to bring engineering disciplines to machine learning. So I tend to have a very applied focus. And this is a very applied topic. In fact, it's a very general purpose software development talk. I'm currently working on an open source project called Guild AI, and I don't think I'm going to get into that, but I'm going to use an example from Guild. That's about it for this talk. This is Chicago ML. I started this a number of years ago. We've grown it at a nice clip. I think we should be bigger. We should be doing more things. So if anyone wants to help out either from an organization standpoint or a contributor of talks or workshops, there's all sorts of things that we could be doing that we're not. My time is unfortunately limited, and it'd be nice to be able to expand that organizational footprint to be doing more in this area. Prior to my work, I was at CloudBees, so I was doing backend systems for platform as a service. Okay, I'm going to be talking about patterns, and when you hear the word patterns in association with software, you're probably thinking of the enterprise book, but we'll touch on in a second, which is sort of a C++ or Java OO focus on software patterns. This is absolutely not that. This is a very different type of patterns talk. It actually goes back to the original source of this concept of patterns, which was Christopher Alexander's work, The Timeless Way of Building, where he outlines a methodology of developing patterns and pattern languages to be used for physical architecture. And the compendium to that is a pattern language, the second book, which is an actual library of patterns to be used for physical architecture. So when you read Christopher Alexander, you're talking about physical spaces that human beings indwell. And the patterns that he develops are all for building and towns and physical interactions between human beings and their environment. And I think this is the design patterns book that you are often probably used to seeing in conjunction with software and patterns. This book would cite Alexander as sort of the inspiration. But when you get into it, you see that they take very different approaches, and I would sort of take issue with this is the Gang of Four, classically known as. I think it's slightly pejorative. I'm not sure that's a compliment to be called part of a gang, but the Gang of Four. This is what it's called, the Gang of Four. I don't think they really treated Alexander's work the way that they perhaps ought to have. But rather used it as a way to enumerate a number of code construction patterns. And this is a very, very popular and well-known book. This is not what I'm doing. An example of the patterns that Alexander talks about, again, related to the physical environment, but he addresses in his book this he calls it the quality that can't be named. And he uses a bunch of names and a bunch of descriptors to identify a certain quality of a building or a space or an environment. And ultimately, at the end, it's difficult to give it a single name. But it has to do with sort of the sense that it gives a person of being alive, and being vital and being part of something that is natural and very sort of effortless. And he draws these distinctions between places that are alive and places that are dead. And if we've ever been in a building that doesn't feel alive, we know spaces can feel dead and spaces can feel quite alive. To take this model and apply it to software, I think is honestly a bit of a stretch. And to do what I'm doing, which is actually not to apply it to software construction, but to software method or software practices, is even more of a stretch. So I'm going to put that out there right now. But I think that the methodology is nonetheless useful. So I'm going to do something that I think is a bit tricky, and I'm not sure Alexander would even feel this was appropriate, but I'm going to try, and we'll see where it goes. Okay, so I'm going to be talking about patterns for Jupyter Notebooks of all things, and this is kind of an arbitrary example. It's only an example because, as we'll see in a moment, the method for elaborating patterns is an emotion-based method. And for some reason, Jupyter Notebooks evoke emotions in people. And I feel like it's a really nice vignette to explore the application of Christopher Alexander's patterns method to software. And so that's what I'm going to do. I have emotions, and I talk to people who have emotions about this. What we're really doing here is exploring the patterns for software development, not for code construction, but for methods, for practices. So there's things that you do as you build software, sort of your patterns of use. Because let me talk about a pattern here. And this is going to be a bit of a bit dense. I've tried to. This is lifted right out of Timeless Way of Building. So I'm going to start to fill this in so you have an idea of where Alexander is coming from when he talks about a pattern. So from Alexander's point of view, it's a 3-part rule that expresses a relationship between context, a problem, and a solution. All right, so it can exist at any scale. And the imagination required here really is, how are we applying this to software? It's, again, a bit of a stretch. So maybe relax your idea here of scale. When he talks about it can be applied to something as small as how do you create a corner or an alcove? Make sure I'm just going to go ahead and limit the background noise here. All right. As large as large extended communities and even neighborhoods and cities. I think you can still apply this to a small software practice to a more aggregate or abstract software practice. So it begins with an observation. What is common among options that feel good and missing from those that don't feel good? In doing that, you attempt to discover some invariant feature that distinguishes good from bad. He has a very specific formula for this, in that it must be precise enough to use. So in his case, it must be precise enough to sort of build. You go out and do something. You build a room. You decorate. You build a garden facade or whatever it is. You can actually apply it. So I think that's an important. We want to stay away from abstractions that you can't directly use. Further, you must be able to name it. The name must be precise enough to use the pattern. So for example, something like code quality, that's not a good pattern. It's too general and it's not something you can use. But short functions, which might describe the size or complexity of a function, that would be a good example of something that you could name as a pattern and use. So with a name, you can share it. So that is, we go to some effort to come up with good and clear names so that we can use them without having to go into great detail about using them or about what they are. So it's like a good, small, short, descriptive name is important in this process. And this is an important distinction, I think, between Alexander's approach and what you often see in software engineering and patterns. The patterns must emerge from feelings and not thought. They must be evaluated based on emotional reaction and not thought. So does somebody to say, this is a pattern for software construction, it's fine, you can say that. But it's important to go further and say and ask, how does an individual feel in using this? What's the actual reaction to using it? Rather than prescribing it as a standard, you might prescribe it, experiment with it, experience it, and then determine if this is a pattern that you actually want to use. Does it result in good software or bad software? It's not enough just to make deposit something. Okay, so let me give you an example here, and it's going to apply directly to notebooks. All right, this has come from a few conversations I've had, and I've changed the names to protect the innocent and guilty. All right, Jane says, I don't really like notebooks. I think they're a bad tool for software development. So I could have everyone go on the record and raise their hand. Who is with Jane on this one? Don't do it. Just you can stay silent here. Well, Jim says, I love notebooks. They're great for a great tool for software development. We have two different perspectives here. So Jane is curious, why on earth do you like these things? Jim says, pauses, thinks about it. It's hard to say for a number of reasons. One is the sense of a blank canvas that they give you. Data analysis is exploratory, almost like an artistic process. Notebooks encourage this mindset. All right, fair enough. Jane says, but they encourage a number of bad practices. Jim says, I know, but I'm not a software engineer. My job is fundamentally different. Does any of this sound familiar? It sounds very familiar to me. I've seen this routine many times in different contexts. So hopefully it may, well, I don't know, hopefully it may ring a bell with you. Jane says, not really. You write software. Shouldn't you be more concerned with the quality of your work? Ouch. Jane is getting personal here. Jim now is defensive. Hang on a second. I'm as concerned about quality as anyone. All right, so now it's devolving into ad hominems and other problematic arguments. So if you don't think that if you think this is perhaps fabricated, I really encourage you to go out and have a gander at these two talks. And it would take you a couple hours, 1 hour each, to watch through them. If you care about this topic, I think these are worth watching. This talk by Joel Gruss was a couple of years ago, and the follow-up to it, which is a direct sort of counterpoint to Joel's talk, was by Jeremy Howard, which was back in October, two years later. And if anyone is familiar with this situation, Jeremy was actually censured or called out for a violation of a code of conduct. They since, after that, retracted that and apologized, and it was kind of a big bit of noise related to this talk. So if you watch either of these, you will see a great deal of emotion packed into the arguments that are made by both parties. So I think I've identified something that has emotional payload. And I think this is a really good, again, a vignette for this pattern problem. Okay, so why don't we take this debate between Jim and Jane and Joel and Jeremy, the J's, and let's see if we can apply a pattern to this conundrum, this particular point. Okay, so going back to Alexander's definition, we need to solve. Okay, sorry. The context of this pattern is we need to solve a problem here, but we don't know where to start. So this is the canvas. This is the canvas problem. This is what Jim was saying. I like the fact that notebooks let me just start as a blank canvas idiom. So I like that. Great. You like that? Let's explore what it is about that, Jim. Why you like that? What gives you that sense of a positive feeling when you use this? And notice in this particular case, we can't debate with Jim. We can't say, Jim, you're wrong. You don't feel good about this. Jim really isn't making an unqualified statement. He's qualifying it by saying, this is how I feel. You can't argue with that. What's interesting there is why he might be feeling that way. So let's tease this out and see if there's a pattern here that we can generalize. And maybe Jane might even just agree with it, because we've worked a little bit to try to articulate for Jim what he's saying. Okay, so the context of this is that we have to solve a problem, but we don't know where to start. And this is often the case in data science. We have to solve a problem, but we maybe have a data set, we have maybe have a model. We've got, well, where do we start with this thing?
It's just talking. You can listen. You don't need to climb up.
Hang on. Okay. All right. Got him. Zapped him. Okay. I'm sure there's a setting here. Oh, yeah, there's mute all. Does that mute me? Mute all. I'm still talking. Good. Okay. Okay. So that's the context. Now the problem is how can we get started and move toward a solution when you're not sure where to start? So a proposed solution would be to provide a way to start typing something that's non-committal, provides feedback, and can be changed or enhanced as we move closer to a solution. Right? And this is actually kind of novel. If you've done software for any amount of time, you've probably run into cases that don't do this at all. They require some kind of model. They require some, UML diagram or class ontology or some sort of forethought. And I think it's very reasonable to say that doesn't feel good. I would like to be able to make some progress on this problem without being shoehorned into some scheme that doesn't really fit my brain right now. I think that's where that canvas idea may be coming from, the motivation of that. All right, so common among the options that feel good is just start typing, executable with immediate results and a sense of openness. Does that sound, like where we're going here? So common options that feel bad would be, this is the right way to do it. You can't just start, you must do it the right way. That's pedantry. That's somebody saying, we have these high standards here, and and that, if you watch Jeremy's talk, you can hear the frustration bordering on anger in his presentation, because he's heard many times people telling him that's not the right way to do it, and so this blank canvas sets that aside. So an option that is pedantic would not fit this pattern. Excessive structure or abstractions, UML models as an example, or class definitions. These would be things that would probably not feel so great. All right, so the invariant that we're looking for would be immediate typing, code execution. So then we just start in, flexible, mutable layout. You get the idea. Okay, so the names that we might use for this pattern could be notebook, because notebooks are really kind of that. That's almost the point of them. We might pick REPL. REPL, we'll get into what, if you don't know what REPL is a language console that allows you to type an expression in, hit enter, it reads that, evaluates it, and then it prints the results, and then it loops. So when you run Python or IPython, those are REPLs. When you execute a notebook cell, that is effectively a REPL. We might call it a canvas. We might call it a code canvas. We might call it a blank canvas. So these are just ideas for names that we might use to describe this particular pattern. Now, I would typically ask, does that make sense? But since I muted everybody, nobody can reply. You can unmute yourself, though. So I'll say, does that make sense? And then in my mind's ear, yeah. Oh, yeah, it makes total sense. Yeah, it makes great sense. Great. Good. Let's continue. All right, before we continue, though, let's do a check, though. We don't want opinions here. We want to sort of motivate by emotion. We want concrete and usable, and so we don't want to get too abstract. Okay, so what I have here is the name blank canvas. So of these options here, notebook, REPL, etc., I kind of went with blank canvas. That may not be the right answer. It doesn't even have to be. Everyone can come up with their own names in their own languages. So I'm just using blank canvas here. The definition or description is a non-imposing facility that enables experimentation with code and supporting content. So I've added supporting content here because notebooks have support for Markdown. And I thought, possibly that's part of the canvassy experience, is that you have code and then you maybe have descriptive content that support it. So I used supporting content to extend this idea beyond just code. A blank canvas presents little to no upfront requirements to the developer. It awaits his or her commands in support of ad hoc, non-committal experimentation. Use this when faced with a new problem and uncertainty as to how to proceed. So examples of these are Jupyter Notebook. Also Python REPLs. Python REPL, you can just fire it up and start to type. Other things might include a throwaway Python script or module. Another one might be getting slightly more esoteric. Unless you have been writing Python for 20 years, you might not even heard of doctest. But there are other ways to sort of get you going in a software construction problem with minimal upfront requirements and that are very flexible. So I named a couple some things here, docfile or similar. So Jupytext with Markdown, that type of thing. Okay. So that's an example of a pattern as applied to that can be applied to notebooks. So now with this blank canvas pattern, we don't really have to disagree about what to use. You know, is it good or bad? You know, is Jupyter Notebooks good for this particular topic? We really have a number of options, and we can kind of cut through the tribal affiliations, because these tend to emerge, right? Some people, tend to just use something and that becomes their thing. And then they start to defend it because they like it. It's emotional. And so we can kind of cut through that and say, hey, well, you know what's great about Jupyter Notebooks is this idea that you can just land on this blank canvas and just start to do stuff. It's kind of hard to argue against that. And you might say, well, but you can do that with other things. And that's true. That is the point. The point is to be able to now name this and use that name in conversation, or use that name sort of in a deliberate assembly of patterns to use in your software development practice. So hopefully with that, Jane and Jim can be less heated. Joel and Jeremy, possibly less heated, though I don't know. Okay, so let's find more of these. And to do that, what I've done is I had a problem this morning. A guild user asked a question on the forum, and unfortunately, guild did not satisfy what he wants. So I went to go and create a little script for him that he could run to do the type of thing that he needs to do. So I did that totally independently of this this talk. But I said, well, why don't I just use a notebook to do that? And then I can sort of have an emotional experience and actually use that as a part of this talk. So this is an earlier exercise that I did, and I chronicled my emotional responses. So the exercise is this: provide sample code. So the problem is this: provide sample code to a guild user to answer a question. So I started with the Jupyter Notebook. I identified things that I liked and things that I didn't like. And I used a couple other methods just to maybe elaborate and compare and contrast different methods, different things to sort of help reinforce and help to define the patterns that seemed to occur to me. So it wasn't just isolated to one tool. It used multiple tools and techniques and looked at the features of those tools and techniques to try to find some patterns. Make sense? To the muted crowd. Can everyone hear? Can anyone? Okay, some gray person, please unmute themselves and let me know if you can still hear me talk.
Yes, we can hear you talk.
Yes.
Fantastic. I mean, this could be totally disconnected. I would just continue, right? Easily possible. All right, so thank you for that. All right, so the Jupyter Notebook reaction. This is my reaction, and again, this is emotional. Now, I'm kind of happy of this little method because it's emotional. I feel free to rant unchecked about things that really irritate me, and I often feel very bad about that because I feel I'm maybe excessively negative, and maybe therein there lies some criticism or implicit criticism of somebody else because this is a tool that other people have built, or maybe a criticism of somebody because they like the tool. So I appreciate, in fact, Jeremy Howard was called out for violating a code of conduct, I think because he was really butting up against this thing, which is like, how unvarnished do I express my zeal or disapprobation for something? Now, I've cloaked this under the Alexandrian pattern elaboration method, which is by definition emotional. So if you hear me getting emotional, don't be alarmed. Don't be alarmed. It's part of the exercise. Okay, I want to talk about the good first. All right, what do I like? What did I like about this? So maybe I should first show you the results of this, so you see what I built. All right, so this is in a notebook, and this is called the guild join example, and it basically is sort of a problem of joining a couple of tables essentially, and so I wanted to provide a complete example for the user that worked. I don't like examples that I haven't run. I can't verify that they work. So I took some time, and this took a while. It started with me. So the blank canvas, let me delete this. The blank canvas looked like this, right? So pretend this stuff down here doesn't exist. So I started with a single cell, and I would do something like from guild import IPY as guild. That's a little weird trick. This IPY is kind of a public-facing API. So I call it guild because it's kind of the only API that we expose. So it's a strange little convention, but like, okay, I got guild, and so I can work with my runs, and guild is an experiment management system. So it specializes in running ML experiments, and those are called runs, the things that are generated. And the point is that you run the experiment, and then you capture information about it. So the user wants to see a certain type of information that guild does not provide. So that's the problem I'm trying to solve here. And so I was playing around with this. I don't remember the API. It's kind of maybe not documented that great. And even if it was, I don't remember as a data frame. I don't remember the data frame interfaces. So I'm like, well, it's something like this, and iter runs, maybe iter rows here. I don't know what I'm getting. I'll print it out. Print. Does this look familiar when you're starting, or you're really starting? You don't know. I don't know what I'm doing. So I see the data here. I'm like, well, how do I get the information I need? And then finally I realized that it's nothing like that. It's actually this thing called compare. And so I can just do this. That took me a while to figure out. So the data I need is actually in this thing called compare. So what is that? Well, it's this thing. Oh, there's the data that I need. So anyway, it was this sort of flopping around in an iterative exploratory process that got me down the path that I needed. Now, eventually, let me just delete this stuff. Eventually, I got to this thing here. So this is the code that's working, and I can run this. So I'm going to say restart and clear all. Okay, so if you've used notebooks, shift enter, shift enter, shift enter, la 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 la. So I can do this to verify that this is doing what I want it to do. And what it's doing is it's running some sample runs with data, that kind of fake randomized data that will be used for this join operation. So here's my compare. These are my runs. And the whole problem here is to take, in guild, there are dependencies between runs. So like, let's say you're doing a training run, and then later you want to evaluate that run. You can express that relationship as a dependency, so that when you evaluate a specific training run. And what the user is asking for is, he said, I would like to see information about the training run reflected as information for the evaluation, which is very reasonable. Unfortunately, guild doesn't do that. It's kind of like a join operation. So I wrote this thing, and this is kind of a manual join. And what this does is it puts values from the upstream, so that would be like the train, and it puts them as new columns for the downstream. So this is the evaluation run. You can see here, this is the information for a single evaluation run, and it now has the information that the user wants. This is just an example. So it works. And then I said, oh, this code needs some quote unquote comments. It needs some structure so it looks good. And so I filled this stuff in. Titles, little, descriptors, etc. And honestly, I think it looks quite nice. And this is, I think, a rewarding experience, because it starts with a great deal of uncertainty. It moves through an ad hoc and iterative process. It gets something to work. and then you can sort of format it and reflect it as a completed work. I think that is unequivocally great. And I think it drives a lot of the love for notebooks, because that process is very much what data scientists do. You're not really sure what you're doing. You start, you get something to work, you proceed, you see more coming together, you refactor something, you move some things around, it's starting to work, great, it's working, and then you kind of tidy it together as a narrative, as sort of a document narrative. So that's what I have here. And returning to the things that I like, I really liked the cell isolation, initially anyway. If you've worked with notebooks, you've obviously familiar with, you're working with cells constantly. All of these little things are cells, and you're always typing in the cells and you're evaluating or running the cells. These are little REPLs. I'm going to take this information, I'm going to run it, and notebook sends it off to a Python VM. It's evaluated, and then it's printed as a result of as an output of the cell. And then you effectively loop by either running it again or running a different cell. So it's like a REPL. These are really just little REPLs all over the place. Kind of neat. All right, so I liked that. So not really knowing what I was doing, it was easy just to start. There are dependencies between the cells, but most of the time I wasn't bothered by that. I really liked initially the openness of the UI. It really does feel like a canvas of sorts. You can just start going and you can do something above and something below, wherever you want. It's nice. Results can be made to look quite nice. The narrative that emerges is simply outstanding. I don't think you can get a better document experience, in particular because you can run this stuff. This is a nice looking report that you can actually execute, and it sort of dynamically updates itself. So I really think that's it's the notebook's strong point. All right, now I've said the good, and that is genuine. That was not contrived. I really believe all the things that I said, but let me now get to the bad. Okay, this is in no particular order. The visibility into state is terrible. And again, this is emotional, so I'm going to use words like terrible and awful and horrible. I said simply outstanding over here, so that was really good. And I'm entitled now to say what I believe in an emotional way. The visibility into state is just terrible. I used forced print statements and odd dangling expressions just to see results. And what I mean by that is, where are we at here? Is this type of thing. This is a pattern that you'll see. Hopefully people can see this. So I'm highlighting this last compare. If you don't have this compare here and you also want to, assign a result to a variable, you don't get to see the result. To see the result, you have to put you have to type that as an expression someplace. Now I can see it. I could put that in a different cell below. This is everywhere. There's no other way to really do this with notebooks. Now, in a notebook, you have an extension called a variable inspector. So I'm going to open this. You maybe can't see it. It's off to the right here. It's this little box that shows things that sorry, you can't see it. Maybe if I did a refresh here, it'll realign. Now, for some reason, it's off to the side. There we go. It ostensibly is used to view state, but it's just frankly not useful. This compare variable, for example, is a data frame, which is quite interesting otherwise, with lots of interesting information. But here it's simply reflected as a string and not even a complete string. Run operation s ... That's the information I get about this. There are 4 rows and 11 columns. Okay, that's slightly useful, but there's no way that I can use this in notebooks. So I'm just going to close that. So what I do is this, and you get used to it, but there are better ways. And if you know what those ways are, you are entitled, in my opinion, to use strong language like visibility is terrible. Okay. Cell execution, that's my first complaint. And again, based upon my sense of I don't like I don't like this. I have nothing against notebooks, honestly. I have nothing against them. But when I do stuff like that, and I have to do it all, and I have to think about things like that, it starts to get on my nerves. Cell execution dependencies bit me multiple times. So what I mean by that, bit mean is sort of idiomatic for they injured me, they bit me like a dog would bite somebody. When you have cells all over the place and you're executing them in ad hocly, right, without a lot of system, not in a sequence every time, it's extremely likely that you're going to get into a state that is simply wrong. It's simply an inconsistent state. It's an undesirable state. And it's not clear at all that you are in that state. So you may assume that you are in a consistent or correct state, but you're not. And what will happen is you'll run into aberrant behavior, something that would appear to be a bug, simply because you forgot to execute a dependent piece of code prior to your current execution. And that is an ongoing minefield of problems in notebooks. It would be in any case, in any REPL, if you execute something out of order, where an upstream, a prerequisite is become effectively stale, it's wrong, it's incorrect, you're gonna get bad behavior. Now, how do you know whether you're correct or not? You really don't. And for me, it became a weighing and nagging source of anxiety, because I would run into, it doesn't take many times. I'm not going to tolerate like spending time debugging something when it's not a bug. And I started to do that. I did that like twice. And I said, I'm not doing this anymore. What I'm going to start to do is run this thing from top to bottom every time, because it's difficult enough just to solve the actual problem you're working on. I don't need more problems introduced because I forgot to execute a dependent clause as I was mucking around up here. Oh, I forgot to execute this thing. It's frankly much, much easier for me to execute things sequentially top to bottom and then not worry, not have that anxiety. Is this correct? Is some weird thing going to happen now? Oh, what did I forget to do? That was an extremely unpleasant experience, and one that I just won't do again. I'm not going to get into that. I'm not going down that road. If forced to use a notebook, I'll use it in a very different way. I will not, as appealing as that ad hoc process was up front, it became really onerous and really anxiety generating for me very quickly. You know what I'd like to do here is I know I muted everybody, but I would encourage, if anybody wants to ask a question or say something, to just unmute yourself. Let me be clear. I muted people because there's background noise, not because I want people to be quiet. So please feel free to stop me. Just say something. I'll stop and we can ask your question or make your comment. Oh,
So far, I'm smiling on my end because it's just everything that you talked about explains my life. Specifically, so going back to the good, where I can just go in and play around with things and move things around. But then when my notebook grows, loading up the notebook gives me so much anxiety because I'm like, all right, I need to run this cell, then this cell. And then trying to edit everything. It's like, there's been so many times when I just ran the notebook from start to finish. But then there are times when there are cells that take so long that I can't do that I have to then go in and figure out which cells need to be run, et cetera, et cetera. So I completely see it. And again, with the emotional, I'm just laughing on my end because it's so true.
So the problem of the what I call expensive state, I think I have another slide deck where I've spent a little bit more time, a fair amount more time on a more comprehensive set of patterns. What I'm going to do here is just I'm running out of time, so I got to run through my ranting, but really try to get to a set of patterns that we can look at here and maybe address these, because maybe there are potentially ways of using notebooks where this particular problem is less problematic. I don't know. I'm having a hard time with that, but I don't want to. The point is not to pry a tool away from somebody who likes using it. at all. It is to shift the argument from tool-specific points to sort of value and what works well and what doesn't work well. And that's a much, much more interesting conversation, I think. Okay, so let me continue with that said, let me continue with my relentless ranting of this tool. The editor is terrible. It just is terrible. I'm an Emacs user, and if there are Emacs users, you're not going to switch from Emacs. You're not. There's probably Vi users or Vim users. You're not going to switch. Maybe you're a VS Code user, and you become used to a certain standard of editor. There are probably not a lot of people here who like Nano, for example, as their primary editor. I mean, Nano is a great editor. It's great. It's simple. It's easy to use. It's almost everywhere. It's usually installed. Frankly, Vi, not Vim, but Vi is a great editor. It's very simple. It's very easy to use. It's usually installed everywhere. But you wouldn't opt for that as your primary editor. When you write code in a notebook, you don't have a choice. You can't pick a different editor. You're stuck in these cells here. And yes, there are ways to do code completion. I don't even use code completion. I'm not even talking about that. You can do code completion here. Yeah, eventually it comes up. It's a really, really rudimentary. I mean, you're talking about an editor implemented inside of a cell, this web browser. So it would be one thing if we could sort of opt out of this and say, okay, I'm going to live my life in my text editor and then somehow integrate this in here, but you don't. You don't have a good, well, there are ways to do it. I'm going to talk about that. So that was a profoundly negative experience for me. I'm going to continue with the bad here. So the cell creation is pretty close to arbitrary. And this, I think, is, for me, one of a handful of really damning critiques of notebooks, is the fact that I have got to think in terms of cells in order to author the notebook. It is not a natural process. It is not a clear process. You can create cells to see things. So the visibility problem, I'm going to create a cell simply so I can see something. I certainly create cells to run things. I create cells because I think it might be the right organization, but I really don't have a good reason. The cognitive load of when to create a cell is always present, and it is distracting. And here's a simple example. Why did I do things this way? I don't know. I mean, the imports, they seem to go together. That's my reason there. Now this, why did I do this? Well, these are kind of related. So if guild home changes, the rest of this stuff needs to change. But I guarantee you, I don't know if that is complete there. And I don't know if it could be complete because the dependencies are never linear. They're generally graphic, graphal. They're graph dependencies. They're DAGs. Why did I do this as a single one? I don't know. I mean, really, every single line could arguably be its own cell, but that's kind of a pain. See, there is no standard that you can apply. And if you have a standard, there's going to be a degree of arbitrariness to it. I just don't see, the cell here is aligned with the developer's convenience. The people who developed this tool, Jupyter Notebook, they designed the cell meme, this motif, for their own convenience. There's no reason that they needed to do this. It's convenient for them. It's because they take the whole cell, they push it over to the VM, it's evaluated, and it's printed into a corresponding output cell. Lots of tools do things differently. I think this is a very rudimentary and basic implementation of a form of a dynamic code execution tool. And unfortunately, you cannot opt out of this either. I can't say I don't want to deal with cells because there's no other way to evaluate incrementally. Let me draw a contrast because this is a point that I know I'm ranting here, but not all tools are the same. We can't just say, well, everyone's entitled to their own personal views here. This is material because if you're using a notebook in an organization, other people have to use a notebook. It's very difficult to collaborate on notebooks without actually using the notebook or using a different methodology. So your preference, I'm saying you, I don't mean to judge, don't think of it as you, one's preference is not necessary, is often not limited to simply personal opinion. It leaks. So if you're building software in a notebook because you like it, well, that's great if you're the only developer who's developing software in a notebook. As soon as somebody else has to do that, they now have to use that notebook. And so I think it bears a very important conversation. Do you want to be using notebooks when they suffer from some of these defects? I know that sounds like a campaign to say don't use notebooks. I'm actually not. I think that there are good places to use it and there are good ways to collaborate. I'm gonna totally run out of time here, but I'll highlight, I guarantee I'll highlight that before the end of this. This is an example of an IDE that has what I think fairly solid notebook-like features that may appeal to folks who are used to some of the really nice features of notebooks. Not all IDEs do this. And in fact, the most popular one, Visual Studio Code, does not do this. It does not do what I'm going to show you. And I'm shocked that it doesn't, because it's such a basic and simple to use, simple to implement feature. What I'm going to do is in PyCharm. And there's a number of really good Python-oriented IDEs. I would name VS Studio, Visual Studio Code, PyCharm, Spider. RStudio, in fact, supports Python code. If you're an R developer, you can use it for Python as well. I don't think you'd probably use it as the primary Python tool unless you came from R. But what these do, with the exception of VS Code, does not do this, is you can execute the current line in a Python console, and then if you have something highlighted, selected, you can execute the selection in Python. All right, so let me just give you an example. So I'm going to hold down Control and press Enter. And what PyCharm did here is it took this line, import OS, it fired up lazily a Python VM, so Python 386 here, and it simply copied the code in and ran it. So now I can just click down here in my REPL and run OS, and it's been imported. So it's like a cell without the cell. So I can execute something. So I'm going to hit Control Enter, and here it goes. And RStudio does this. Spider does this. Visual Studio Code does this, but it supports this, but only for some reason if you're running a notebook. It doesn't do that with the normal Python modules. It's mind-boggling. So if I wanted to have a very notebook-like experience, what I can do is just hold Control down and press Enter. And now I'm just executing the code. Now I'm here at a statement that is multi-line, so I have to highlight the entire statement and execute it as a block. This is very similar to executing cells, except you control what's executed. And you don't have to think about cells. There's no cell abstraction here to worry about. So this is literally the same code. I just copied it in, a little bit of a modification. And I'm getting the same kind of feedback, but it's separated from the document. It's separated from my code. So in a notebook, the code and the output and the evaluation are all mangled together. And I use mangled as a negative. I mean that. It's a mess. It is just a mess. The fact that output is stored with your notebook source, and that output is a function of an environment-specific execution in time and space, is mind-blowing to me. How inappropriate that is, to couple source code with evaluated output that occurred at some point in time. And worse, it happily saves it in whatever order you executed it in. So you have this intermingling of source code and output. And I didn't list that as a pain point because I didn't experience that pain point, but that is a critique I have. If you do something like this in PyCharm or if it's Spider or whatever, this code is separated. It is the long-running static code of your project. The execution output is ephemeral, which is what in fact it is. This output is meaningless in the context of source code management. Nobody wants to see what you ran at a particular point in time on your machine coupled to your source code. It can only be a distraction. Instead, what you want, you do. In my opinion, this is my opinion, and it's not, I've deviated from the Alexandrian approach here. I'm just ranting. What you want is, what traditional software would do is you run this as a test. You run this and you generate a report which is based on that point in time execution, and they're separate. The report results do not go into source code alongside of your code, because that code execution can be done on n environments over m times. It doesn't make any sense to couple these things. Yet notebooks somehow do that. So this is an example where I have, I did this. You can do the same thing. So let me show you here. I'll comment this out because I want to get to the canvas pattern, because that was sort of the lead in here. So let me make this all disappear. Let me kill my Python session. Let me come up here. This is a blank canvas. Let me make it go all the way, right? Blank. I even changed my color scheme to white. I typically would have a dark scheme here because this makes it look more like a white canvas, right? It does. This looks like a canvas. It's totally blank, and I can do things like this. From guild import IPY as guild. I just held down Control Enter and executed it, right? So now I have a live VM here that I can mess around with, and it has no effect whatsoever on my code up here. Now I can say, well, what's runs? Guild runs. Control Enter. I'm now evaluating that. Over here on the right, we have what I would call a proper honestly, I'm going to be a little denigrating here, circa 1985 style variable explorer, where you can actually, see the state of the variable. It isn't just a, printing of a string rendering of this. It's actually useful. And I can see this thing as this is going to be empty. Is it empty? It's got 3. So I should be able to, interesting. Okay, so for some reason, I know that PyCharm lets you view this as a data frame, but for some reason it's not letting me do that. And I don't know why.
Hey, Garrett, this is Ted. I don't know if you're interested in comments along the way, or maybe
please,
we wait to the end, or.
Yeah, I don't know. At any time, anyone can stop and.
All right, thanks.
Questions or comments, please.
So a comment, if I may. I think, I've had very similar experiences with Jupyter, and can reinforce that the shortcomings that you've mentioned, the things that you don't like, are generally, things that I've now changed the way I use Jupyter so as to avoid them, right? So for example, what you talked about, like, I always run things from the very beginning. And in fact, if I see a notebook and the cells aren't actually labeled execution 1, 2, 3, 4, 5, if I see 10, 17, it freaks me out. Okay, so all that stuff. So there's certain patterns. So like a lot of the notebooks that I have, if it's things I'm going to be working on, not just like a one-time throwaway, then you'll see perhaps it will be a cell for imports, a cell for sort of like constants, global variables that are being defined. Like if I'm doing something, batch size equals something, configs. And then everything after that's going to be function, 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 no returns whatsoever. And then at the very bottom, I have the real code that just executes, a certain series of things in order, right? So that's very consistent with everything I think that you've shared so far.
Well, I'm gonna capture this because I think this is the process that I think is the really potent process, which is you've identified something that you like, and we can actually run a little exercise right now. I want to just capture this. First of all, I'm just going to capture it in my own words, because it's not obvious to me what pattern you're describing, but I know that there is a pattern and we can name it, and it could be a very useful, could potentially apply to all sorts of things. So let me see if I can describe sort of like a convention for cell creation and use in notebooks. Imports, constants, functions, and we'll call it story or function use.
Yep. And then one thing which actually maybe is more the key point that I wanted to make, though, is that I do use notebooks sometimes just because I'm used to using them, and would admit that I would probably be better off just going to PyCharm and doing stuff there. But where I really want notebooks, so I use notebooks and I use R Markdown, is explicitly because I want something that is going to communicate. It's not for writing my code, it's for communicating my thought process. And so the exact opposite of what you said, I explicitly desire a tool that will intermingle output with code when I'm doing that. Okay.
Okay.
So I can say, let's check to see if there are NAs in this data. And I run some commands and I demonstrate output. And then I say, okay, in this particular column, there's enough NAs that we are now going to have to decide to do something about it. So am I going to fill them in with medians? Am I going to, and now I'm going to write some code in order to figure out how I'm going to resolve that NA problem, right? So in a situation like that, the final code definitely, I agree with you, is not better for having been broken up into cells. But it is much easier to communicate to someone, here is this thought process that may be 20 steps long. It has, some plots in it. It's got some tabular data in it. That's when I think notebooks are more like a paper lab notebook, and they kind of serve a purpose, versus no, for just writing code to demonstrate or calculate something, I don't think they're the best. So that's I don't know, my 2 cents.
No, I think, and I'm going to go through. So the PyCharm example, okay, this separation. This is a good delineation, I think, because here there's quite a deliberate separation of the code from what the code does / generates, and that's a feature. And where it's not a feature is obviously there's not a lot of narrative if you just look at this block. And even if you were to fill comments in, it doesn't, as you say, it doesn't capture the result. So you really don't have the full story. So this would be, obviously, there is probably no one approach that satisfies everything. Though I'm going to show you one thing that might, and it actually I think would reinforce the desirability of notebooks, because what I'm going to show you, nobody's going to want to do.
Cool. Thanks, man.
Okay, so let me. Okay, you get the idea though of PyCharm, and a lot of my motivation is here's okay. Let me go back to my dislikes, because I actually get to that point. Okay, so we talked about the cognitive load of cells, and Ted is offering a way to potentially lessen that, because you reduce that, because now you have conventions. So that would be a great pattern to have. All right, so this would be the problem. You'd say the context is I'm developing a notebook. The problem is I feel this cognitive load. When do I do this? When the solution here is a template or a standard or a convention for how to create cells and in what order. So we could add that as a pattern. Okay, so because of my I'm going to continue with my dislikes here, my bad experiences. Because of my apprehension of incorrect state, I found myself executing the notebook from top to bottom more and more. And this is in fact exactly what I did. I ran into some bugs that were related to code execution order, cell execution order. I'm like, I'm done with this. I'm now just going to start running this from top to bottom. But this seemed to me to undercut the value of the flexible ad hoc layout. Okay, bad continued. The autosave, I don't understand what's going on here, why anyone would want this. I found myself dealing with this dialogue that said, something was overwritten. Do you want to overwrite it? I like saving files in the background when you're authoring source code is anathema. I just can't even believe it does that. It does it. And maybe you can disable it. You probably can easily disable it. I don't know why it would even be a feature, but it is. No ability to run ad hoc code without modifying the notebook. This isn't the end of the world, but it sort of is I feel a really quite a painful. This is, I left this in deliberately. This cell here is an example of a cell that does not belong in the notebook, but that I created because I needed to run that code. I wanted to know what VM I was running. Now, all of a sudden, it's a permanent part of this notebook. And if you're like me, you forget things, and it's like, why is this in here? Probably because it's probably a mistake. Oh, I'll delete it. Let me just delete this. But now what? Did I just break something? So it may seem innocuous that you have to, if I just simply want to know what VM I'm running, I think that's a very simple problem. Like it is. What VM is this? I have no idea. It says Python 3 up here. And I click on this, it doesn't give me any information. If I go up here, it doesn't tell me anything. I don't know what's going on. So I know I can find out here. Executable. And I can run that. Great. What I really want is something off to the side here that will not modify this code. And in every other environment that I would ever work in, this would exist. So I can just do this. And I can run this and discover what VM I'm running in. And my code was never changed. So there's no temptation, there's no possibility of this weird code landing someplace in the source code that I care about. I'm almost done with my rant.
Have you looked into NBDev?
Oh yeah, I certainly have. NBDev is not going to help me in that case.
Well, if you make your notebooks, then you just put the hash export, and then that would go into your library, your PY files.
Yeah, but in the
not
meantime,
the source.
my notebook has cruft in it for no earthly reason. And why the authors of Jupyter Notebook in 2021 don't have a REPL over here, because they can. They're doing it all over the place, where you can run ad hoc experimental code without modifying your and on top of it, it auto saves. I mean, if somebody cares about the source code they write, which I do, I mean, everyone should, this is mind-blowing. It truly is mind-bogglingly blowing that you have to modify your code, your notebook, to experiment with something, and then on top of that, it auto saves. In NBDev, sure. I mean, you can avoid the cruft because then you can comment things and then export them. But this is working around this. That to me addresses a problem, a different type of problem. That this is a case where I think you're talking about using a notebook, which I would agree with Ted. It's very hard to imagine a better tool. I can imagine a better tool, but I mean, this is a very, very good tool for what Ted is describing. Fine. I don't think that this is debatable, but the Jeremy Howard school of thought here would say, well, let's take that scenario and apply this as a general purpose IDE for Python development. It's incredible. It's an incredible, and you might be able to push as far further and further and further with the right backfilling of functionality, but all of that is fixing problems that don't exist anywhere else. It all is.
For what it's worth, I completely agree. I don't know why there isn't a console window where you can just type stuff that's not in a cell.
I mean, they could add that. I mean, they could add it. I'm just talking about the things that make me like want to pull my hair out. Like, wow.
Yeah, no, I'm agreeing with you. I'm saying that to me, that seems like a very simple thing, and people who don't want it can minimize it and never use it and just pretend it doesn't exist.
Exactly. There might be an extension. there's so many extensions for it. It certainly might already exist. Surely it exists. Okay, so let me finish this up, and then because I would like to try to sprint here to a finish, so we can have a conversation at the end here. Because really, this is more or less giving you a flavor of the things. This is not meant to be a comprehensive, thorough patterns elaboration. So let me finish my little emotional diatribing here. And then I'm going to show you a list of things that I think could land as patterns as a result of. So what I did is, I'll finish this up. What I did is I reviewed these notes and then came up with things that I think could land potentially as patterns. Okay, so I don't know what to do with the code other than to show it to someone. Oh, right. And this is, again, sort of Ted's point. This code that I write is great if I wanted to show it to someone. And in my case, that's exactly what I wanted to do. This is never going to run in production. This is only ever an example. The fact that the user could run this, it's really, really great. So I honestly think it's the best artifact to hand over, and I will hand it over, because the other artifacts aren't as good. So despite all of my angst and even rage here, the notebook is gonna probably win as the artifact that I hand to this person. This is a document, but the code to me otherwise feels trapped inside. So as an author of software, I see this and I'm like, well, what would I ever do with this? I have to copy it and paste it someplace and then modify it, and like, anyway. And then finally, I don't know if the code is still working without careful manual inspection. And this gets into the testability of notebooks. There are ways to test notebooks. They're not terribly different from the ways of testing normal Python code. So I don't think this is a particularly hard problem to solve. But I did find myself really anxious about the correctness of the code. But I would, under any circumstances, without some tests. So I don't think that's necessarily a notebook-specific observation. Okay, so this is just the recording of my emotional states. Out of that, I feel these are what I'm calling patterny, things that might land as patterns. So this idea of a canvas, the idea of a REPL where you can freely type something, evaluate it, and it doesn't necessarily affect your source code, your long-running code. This topic of state stability, state changing all over the place, and it being somehow corrupt and causing unexpected behavior or spurious bugs that aren't bugs at all. Missing editor features, or somehow a list of editor features that could be patterns. This idea of a code narrative where we have this top-down, really nice, I think, sort of expose of this story. I really think it's beautiful, and I think this is what I would like to hand to somebody, etc. There's a long list of things, and this is just this one little exercise. Strict code control, clear on all. There are patterns that are under here. I didn't take time to think about what the names would be. So here's some pattern examples. I actually filled these in. I use this template. So there's a name, there's a short description. Why is this helping to make the experience feel alive? This is language from Alexander. Where I want to use it, and some examples. So we've talked about this canvas idea. You've seen this already. So that's just a duplicate of the previous. Print statements. I'm not sure this is a good pattern. This is probably an anti-pattern, but it did come up. Use a print command to show variable state. You certainly use this in C. You certainly use this in languages that don't give you ready access to dynamic environments. So during ad hoc development, it's often useful to view state by running a command rather than using a variable explorer. So these are the two examples that I came up with there. The variable explorer, I think, is a terrific example of a really concrete pattern. This is a pattern. This guy over here, for some reason, run does not show as a data frame. I think this is weird, but compare does. So I can actually view the compare result here as a data frame, and we can see it. This is a beautiful thing, and I really kind of wish I had this in my Emacs environment. But I'm not going to switch over to PyCharm. Here's an example of where maybe stubbornness is getting in the way of. I probably wouldn't use this enough to justify it, but it's really nice when you want it. All right. So use variable explorer to answer questions about the state of a program. The REPL pattern, we've seen that here. You know, the ability to run code here without modifying. That's great. It's terrific. The fact that this is tied in, that this editor ties in the source code with the REPL and makes it easy to essentially copy and paste into that, I think is terrific, coupled with a variable explorer. The same version in Notebook is endemic to the Notebook, right? These cells are REPLs. So here the difference is basically you're capturing the output as a part of the document. For better or for worse. We've seen where it can be good. We've seen where it can be, in my opinion, bad. But this is the pattern. A stable code pattern, one might even call it source code, I guess, but the idea of something that's long running versus something that is ephemeral. So I want this code forever, but maybe this sys executable I don't want. So the long running code, I think highlighting that as a particular pattern or stable code might be a useful pattern. I don't know if this may not be a good. I find myself talking about stable code as sort of an important topic. So I have this in here as an example. These are just examples. All right, refactor. We haven't gotten into that, but what happens if you want to get into this thing and refactor it? What does that even mean? What does it mean to refactor code in the context of a REPL? I can certainly tell you what it would mean here. I would start to break these into functions, and it would be a very, very, very different piece of very different looking code. I would not do that here. I would not want to spend time in these little cells writing functions that I can't even really evaluate or effectively test. So I think that's why you tend to see, I don't know, I tend to see notebooks with a lot of imperative sort of top level global statements and not a lot of functions because it just doesn't, it doesn't make a lot of sense to, I know Jeremy Howard does it. And Ted, you described, you know, a section where you define your functions, but that may be sort of after sort of a cleanup phase after you make sure everything's working. Refactoring that kind of code in a notebook, I would try it. I'm skeptical it would be pleasant, but anyway, that's a pattern. Okay, so etc. So there are more patterns. I'm not going to get into them. So here are sort of a recap of the tools that we've covered. Jupyter Notebooks. I didn't mean to say that. I mean to say Jupyter Notebooks. All right, so there's Jupyter Notebooks and then optionally Jupyter Notebooks plus some other tools. We mentioned NBDev. This is a way to, NBDev is sort of a general toolkit of things that help notebooks possibly be used as a general purpose editor for Python code. Certainly Jeremy Howard argues that. And there are people who use it and like it. So well, you can't argue with that. If you're familiar with NBDev, it's okay. Anyway, this is an option. So it's an option whether you like. You know, you drill into these things to examine the patterns within the option. That's the point. All right, Jupytext is a very interesting tool. I'm going to show you this really quickly, and I'm almost done here. Jupytext. Let me bring up the website, Jupytext. I would describe this as a bidirectional synchronization tool that allows you to both export and it allows you to synchronize different language artifacts with one another. And the main hub is intended, I believe, to be a Jupyter Notebook. And I'll give you an example. So what I can do with Jupytext is I can author my work here in Jupyter Notebook. And then I can effectively export or synchronize, or generate different alternative artifacts. So they could be markdown files of different flavors of Python scripts, and I'll actually demo this. So I have my notebook, and one of the problems is that notebooks, frankly, are really not very good editors. They're just not a good authoring tool. They just aren't. They just aren't. It's hard to argue that they're good. I don't know. You can. I just think it's It's a stretch. So let's say you want to use your editor of choice. Okay, here's a non-controversial statement. Jupyter Notebooks are not a standard protocol the way that standard plain text files are. And therefore, you don't have an option to use something different when you're dealing with a notebook. So in every other language that I'm used to using, you can use Vi or Vim or Emacs or Nano or GeoEdit or Pico or VS Code or anything you want. You can use stream editors to edit files. Not so with notebooks. You really need to go into this web interface and use it as your editor, full stop. Too bad if you don't like it. Now, Jupytex makes this so that you can get your useful stuff out of the notebook into a format that you can edit with anything that you want to, and in a format that may be better under certain circumstances. So let me demo this. So what I'm going to do is I'm going to run Jupytex with sync. I just started using this today, so I'm a little slow with this. And I'm going to take this example, guild join example, blah, blah, blah. Guild join examples, IPyNB. All right, that's the notebook. And I've configured this notebook to synchronize with various different file types, if I can get it to stay open. So the notebook is auto-saved. I don't want that. I've unchecked that so many times. I don't know why it comes back on. Okay, so it's set up here to pair with a markdown, and then I'm going to pair it with a % script. All right, so now with that, I'm going to synchronize it. And what Jupytex did here is it went into the Jupyter Notebook file, and then it exported a markdown version and a special, there's two. Oh, I have to save this. Sorry, let me save it first. Okay, now it also created the Python script. So let's take a look at these things. So I'm going to open the Python script, which is here. Okay, and it uses this % format. And if you've used, I think VS Code, and I think even PyCharm supports this, this can be used to effectively generate your notebook-like output, but it's all in a single Python script. And I can edit this thing. Let me make a change to this, and then I'll synchronize it back. So now I'm in my editor of choice, Emacs, and I'll just say print. All right. Now, I don't know how I would run this. Maybe I can just run this. I probably can. I can probably just run this Python. Come on now. Python guild join example py. And okay, I'm running this as a totally standard vanilla Python script. Great. I am now, my heartbeat is lowered, my blood pressure is lower. It's all normal. Everything is normal. Now I save this thing. I saved it. And if I do a sync again, I have to reload this. This should now reflect the modified code, and it does. So what does this mean? This means you can use a notebook sort of as a system of record. It's sort of like your hub, and then use different formats to author this or modify your this notebook. So I believe this is a story for a much more social and collaborative process with notebooks. Whereas without this, everyone is forced to deal with notebooks. Everyone is forced to go in. And as far as I can see, the ND dev integration is not even close to this. It has a very limited bidirectional support. It's primarily used sort of as a stopgap to make small and minor changes. Whereas this is, I think, feels like it's at least trying to be a complete round trip solution for these synchronization problems. So I think this is very, very, very promising. It may all be there, I don't know. But if you are in a situation where you use notebooks, but you also have software engineers who are doing other things with their code and not going to be using notebooks, but you still want to integrate with notebooks, Jupytext may be a very smart tool to use for that. Okay, Python IDEs with the run selected code or the current line. Unfortunately, VS Studio does not do this, shockingly, but one presumes it would at some point. So that I feel is a very solid option for notebook-like ad hoc iterative exploratory development without actually getting into the restrictions of notebook. Okay, I'm going to show you one last thing, which is like circa 2000 maybe technology, but it's really, I think, quite cool stuff. So I use for Guild something that I think satisfies everyone's concerns, but I don't expect anyone else to use it because no one does. No one ever does this. This is old doc test, and it's this is one of the early, novel inventions from Python. And it's been with Python, I think, ever since I've been using it. I don't remember the date. I think 1996 or something. It's been around a long time. And the idea is that you have a text file, and that you embed Python code, and you use these chevrons, these greater than symbols, not chevrons, greater than symbols, to denote Python code. And you'll see, if you look at the Python documentation, the core documentation, you'll see doc test examples everywhere. Now this code can be executed, and what the doc test module will do is it will evaluate each of these blocks, and then if there's output, it will compare the output to an assertion, to some sort of test. I'll give you a very simple example here. If I do 1 + 1, the answer is 2. So I'm going to run this as a doc test. And we can see the command, by the way, is I'm just running Python, I'm running -m doc test module, and then I'm pointing to this file. It's a very simple command. It's saying, oh, you said 1 + 1 is 2. You expected nothing, but I got 2. So what I do here is I satisfy this test. And Ted, this is an example of output that exists sort of as a test assertion. So it's not really generated, but every time you run the test, that output is generated and then compared to what you expected to do. It is not the same thing. It's very difficult to use this to assert values in a data frame. The data frames are not always printed consistently. So this is not a drop-in replacement by any stretch for Jupyter Notebooks. However, it has the threefold advantage of good documentation. It can be used to test, and it can also be used to create readable documentation. So we have our docs here as the primary mode. We are embedding code, we execute those, and we test against it. So I'm going to run this test again. All the tests are going to pass. So this is an example of running something from top to bottom in a document format. This is not, this is like a notebook. And I'm using plain text, I'm using Emacs. I can search and replace, I can do all sorts of things. It's sitting as a plain text file. It's not auto-saving, it's not doing weird things. It's very stable, but it does give you that advantage of sort of a report-like, reproducible, runnable artifact that can be used to communicate and also to verify. So this is why I use it. In fact, all of the Guild tests are written here. I'll just show you some of the Guild tests, and then I'll be done. I'll summarize and then be done. So let me just show you. Nobody cares about this, but needed. Okay, so this harkens to the narrative advantages of a notebook, which people like. The ability to write prose that describes something. It has the advantage of also running it. It has also the advantage of asserting behavior. So if this were B, for example, and I were to run this, I'm going to say make. This is wrapped in a make command here. This is now running this document, and it's complaining that this is expected to be B, but I got A. Okay, so that's why I have this included here, Python modules with tests. So to summarize, I believe it's possible to apply Alexander's patterns to software methods / practices rather than, or in addition to other things like software construction, like here's a code example, here's how it fits together from a construction standpoint. I think you can do the same thing with practice, with methods that you apply to your day in and day out use of different tools in software. Patterns cut through unconstructed debates to identify specific features that contribute to or work against good practices. So I like them because they really help, I think, move conversation forward in a productive way. And it embraces when somebody says they feel good about something, you just don't debate that. That's your starting point. And then you work to try to figure out what is positive about this, what do you like about it. And that is an incredibly, I think, productive exchange. Patterns are informed by emotion, not thought. Does it feel good or does it feel bad? This is lots of information. This is sort of his theory, is that these patterns are really very natural. They come from patterns in nature, and what we ought to do in the work of elaborating these things is pay attention to what's going on in ourselves as signals, and use those signals to then work to try to elaborate and explain what is good about this and what is bad concretely, so that we can use it. They take effort to identify precisely, to use, and they can be shared if they've got good names. And then they can further be used to compose languages. There's sets of patterns that can be applied in various contexts. So good pattern languages lead to good methods. Bad pattern languages tend to lead to bad methods. I would quite frankly, and I'm on the record here, say that there's a lot of patterns in some enterprise books that have led to some very bad software because they're bad patterns. All right. All right, so we know this is a bit of repetition here. So that's your takeaway is this. Your assignment is this: be aware of what feels good and what feels bad when you're doing your work. Consider the features of the thing that you're using that contribute to that sensation, that sense that you have. Look for the patterns, and then adopt the options that use the patterns that you like. I think this is a very good. We can all do this. We can all pay attention tomorrow. After this talk hangover, like, it's too long. We get up and go to our day. We sort of notice what's feeling good about our work and what's feeling bad. And then maybe later at the end of the day, think a little bit about why some of those things felt good, why some of those things felt bad. And maybe out of that, you'll discover some changes that you can make and improve your practices. Okay. So with that, I think this has been running for about an hour and a half, which is a very, very, very long time to listen to somebody. So why don't we keep this to a few comments and questions, and then we can wrap up.
So Garrett, I have a recommendation, but I'll preface it by saying that I fully expect no one to follow this recommendation. So I use both Jupyter Notebooks and because I use both Python and R, I use R Markdown. And I'm guessing that you haven't used R Markdown.
I haven't, and Jupyter actually supports that as well, but I've not used R Markdown.
So the nice thing about R Markdown is that it addresses virtually every one of your dislikes. So you do it in the RStudio environment, so you get your console, you get your full variable list, all the functionality of the IDE, right? It's in a regular text editor. You don't have this funny notion of cells, but you do delineate code. It's not with percents. In this case, it's with back quotes, you know, but you do delineate it that way. It's got the regular integration with, you save when you want to, with version control, all those kinds of things. And effectively, you can imagine that it's like Jupytext and Jupyter combined, because you're working in a plain text code editor, but it knows what's Markdown, it knows what's code, and when you want to actually create the output that you want to share with other people, it sort of stitches all that stuff together, and then you can export it as HTML, as PDF, as whatever you want, right? That kind of stuff. So I haven't actually tried it. I'm pretty sure you could use R Markdown with Python if you don't want to use
You
Oracle.
can, and I list R Studio as one of those options,
Yeah.
very much because of that. This is an example I have up here. This is not R Markdown, but it is a form of Markdown. I mean, it's standard Markdown with some forward matter here, and it is very much like that. I don't know where you would run this. I think what R Markdown is really tightly coupled to R Studio. I don't know of a general IDE.
Yeah, I don't know of anything else
that
either.
you would use.
Yeah.
So it makes sense to use that with R Studio.
Yes, absolutely. I mean, I've only used it in R Studio. It's the same thing. Basically, you've got the 3 back quotes, and then it would be R instead of Python. But to delineate your code blocks. So the one thing they are text files. You could edit them in an Emacs, but you're kind of sacrificing because that gluing of things. Basically when you're rendering it to say HTML or PDF, that's really actually you can. I take it back. You actually can do that. You can run your own little commands like knit and whatnot. I haven't ever done it. I've only done it with the IDE. So I just click the button that says, make, right?
Yeah.
So now I think about it, you actually could work around that.
RStudio also dynamically updates based on your, it doesn't have to execute the entire script.
No, you can select parts.
It'll evaluate it dynamically as you change it, so you can get a continual view. But that's a good example of, so RStudio is, I think, there's a reason that the R community don't use Jupyter Notebooks. And I think it's a good anecdotal data point that an entire community is of statisticians and data scientists and increasingly machine learners is somehow productive without that particular tool, or anything like that tool. And how do they do it? And Ted has articulated exactly how they do it. They have drawn this line. No doubt, Jupytex is an adherent to that R principle, that R Markdown principle, and is applying that in the Jupyter Notebook ecosystem. It also is applying it across lots of different artifact types, which I think is interesting. It's sort of a hub, a translation hub, that is really addressing this problem. Now, I personally don't have any use for anything like this. And until there are IDEs that are like Notebook that can kind of render in place, and maybe VS Code does that. I don't know if folks are using VS Code because it supports notebooks, and PyCharm the pro version of PyCharm supports notebooks. I don't know how those work, what those experiences look like. But I'll say this talk is not at all advocating for one tool or the other. It's really advocating to peel apart the features that we're looking at here and finding a set of patterns that enable the best possible experience, and we can avoid the worst possible experience. And I will say,
and in fact, you've actually helped me articulate now with this patterns as to this is actually why sometimes I'm a lot happier when I'm creating R Markdown documents to share with people than when I'm creating Jupyter Notebooks to share with people, because otherwise the experience is pretty similar. I have Markdown blocks, I have text block, code blocks. So thanks for the patterns distinction.
Yeah, you're welcome. There's a lot more there, and this can go well beyond IDEs into all sorts of interesting things. But I like that idea of the emotional informed process. Any other comments or questions before we wrap up here? Okay, well, with that, we are officially done. I would say that if anyone here is interested in presenting at a Chicago ML meetup, this is what they are. This is what they look like. They're fairly informal, as you can see. Thanks for those who stuck around through the whole thing. I'll have a video of this up, later tonight or tomorrow, for those who checked out early. Thanks everyone for spending your evening here, and we hope to see you next time. Have a good evening.
Thank you very much.
Thank you.
Thank you.